Inverses of relations. So if you remember back from grade 10, we talked about functions and relations. A function is a relation in which each element of the set A or the domain is mapped to one and only one element of set B. So 1 is half of 2, 2 is half of 4, 3 is half of 6, 4 is half of 8. Or negative 2 is the square root of 4. 2 is the square root of 4. So it could map to the same value, but these are always different. It's always a one-to-one relationship. It just means that here I could have them pointing to the same one. The inverse of a function is a relation which undoes what the original function did. So if this relation here was to take half, 1 is half of 2, the inverse would be that 2 is the double of 1. If this one is that negative 2 is the square root of 4, 4 is the square of negative 2. Now if I look at the cases above, is this a function? Is this a map where this element goes to only 1? Yes. Is this a function? Why not? Because it goes to more than 1. The 4 could go to the negative 2 or the positive 2. So it is no longer a function. Other things to remember with inverses. In an inverse function, the domain becomes the range. The range becomes the domain. That's what an inverse means, is I take that xy coordinate and I flip it around. So it becomes a yx. And the inverse function may not actually be a function itself. So, if the operation is putting on your socks and putting on your shoes, what's the inverse? No. Taking off your shoes and then taking off your socks. So it'd be doing the opposite. So taking off . Maybe I should put instead of and, taking off shoes, then taking off socks. So if a function asks me to multiply by 2, what would the inverse ask me to do? Divide by 2. If a function tells me to square it, the inverse would tell me to square root it. If a function tells me to take the reciprocal, what would the inverse be? So if I give you a number, so I'm going to give you a number. If I take the reciprocal, what do I get? Now, if I give you 3 halves and I tell you to get back to 2/3, what would you do? Flip it back, and flipping means to take the reciprocal. So the inverse would be doing the same thing. If the function is to divide by 3, then add 1, what would the inverse be?
Subtract 1 and multiply by 3.
Yes. So subtract 1, multiply 3. Of these 4 functions and their inverse, or of these 4 inverses, which of these inverses results in a non-function? So in which case could I get 2 possible answers? If I multiply by, or sorry, if I divide by 2, can I get more than 1 possible answer? No, for every input and I tell you to divide by 2, you're only going to get 1 output. If I give you a number and I tell you to square root it, is it possible to get more than 1 answer? Yes. So that is not a function. If I give you a number and I tell you to take the reciprocal of it, are you going to get more than 1 answer? Nope. So that makes it a function. And if I give you a number and I ask you to subtract 1 and multiply by 3, am I going to get more than 1 possible answer? No. So the circumstances that we're more likely to get a non-function is when we're dealing with square roots. Because when you take the square root, you can get a positive and you can get a negative. Now, suppose in our mapping question from the previous page that 1 to 2, 2 to 4, 3 to 6, 4 to 8 were to become ordered pairs. 1 and 2, 2 and 4, 3 and 6, 4 and 8. So the squiggly brackets tell us that we're dealing with a set, and then the ordered pairs are bracketed for each. The inverse would be taking each ordered pair and interchanging them, flipping it around. So instead of 2 and 4, I would now have 4 and 2. And then I would have
6 and 3.
and finally
8.
So the interchanging of the ordered pairs of the first and the second coordinate goes to reinforce that the domain becomes the range, and the range becomes the domain. So I want you to work on class example number 3. Write the set of ordered pairs for the inverse, graph both of them on the same grid. So what do you notice about the 2 sets of dots? This set of dots right here were my original coordinates or original ordered pairs, and these ones here were my inversed ones. Do you see any patterns? They're reflected. It looks like I could put a mirror or I could put a line on the graph and reflect it over. Where would you put that line? What would be some of the points on that line? 0 and 0, 1 and 1, 2 and 2, 3 and 3. Okay, so if I drew that line, there's my mirrored line. What is the equation of that mirrored line? Y equals x. Whenever the x value is, the y value is the same. And that's an important thing to know, because that's how I could find the inverse of a function graphically. So if I gave you a graph, and I asked you to determine the inverse of the function defined by that graph, what you would do is you would use the line y equals x as a mirrored line, and then you would reflect your points across that line. Because you could be given a function, and this happens a lot, where you're given a function, you're not actually given what the equation is. And it might be even a piecewise function where it's in different sections, and you can't actually graph it on your calculator. So you need to understand what the inverse means on a graph in order to be able to answer the question. So if I look at class example number 4, it says sketch the graph of the inverse functions defined by the following and then state whether or not the inverse is a function. So what I would do is I would start off with my mirrored line. So if I make my mirrored line, it's the line y equals x. So 1 and 1, 2 and 2, 3 and 3, 5 and 5, 10 and 10. That's my mirrored line. And then pick points on that function and reflect them. So if I look at this point here, it's got coordinates of 6 and 0. The inverse would be 0 and 6. And then I've got this line right here, which is at 0 and negative 6, would become negative 6 and 0. So there's this portion of the line reflects that way. And then this point here, which was at negative 6 and 0, becomes 0 and negative 6. So there's my reflected line. Is that line a function? Why not, Hannah? Doesn't pass the vertical line test. So I can check functions with the vertical line test. If I draw a vertical line, does it cross the graph in more than one spot? So this is not a function. And if you want to write over on the side what the vertical line test is. Okay, so I'm going to give you a moment to do B. So if I look at B, I start off with my mirrored line, and then I take the inverse of these 3 points. And then even though the points are there, and I could have drawn them without the mirrored line, by putting that mirrored line there, you really see the reflection. Whereas without it, it could be a little bit more misleading. But now I can see that reflection. So that's how I can draw the inverse graphically. Algebraically, is this a function? No, because it failed the vertical line test. Okay, question 5. Consider the function defined by the equation y equals 3x plus 2. Find an equation in the form of y equals mx plus b for the inverse. To find the inverse of a function defined by the equation, interchange the x and the y and then solve for y. So what that means is I start off with y equals 3x plus 2 and I interchange the x and the y. Where I see a y, I put x, and where I see x, I put y. And then I isolate, I solve for that y value. So how do I get y by itself? So subtract 2, and then what did you say? Divide by 3. If I have to write it in the form y equals mx plus b, I would divide each term by 3. So x over 3, I can look at as being a 1/3 x minus 2/3 equals y. So now if I graph both functions on the grid, y equals 3x plus 2, in terms of my mx plus b, what does the b tell me? So the y-intercept is 2. What does the 3 tell me? So the slope, rise over run, go 3 up, 1 over. Or I could go 3 down and 1 to the left. So this becomes my original line. So this is my y equals 3x plus 2. And that extends in both directions. And then I have a 1/3 x minus 2/3. So the minus 2/3 tells me I would be at about negative 2/3 for the intercept. And then my rise is 1 up, 3 to the right. So it's a little bit harder to draw this one. So 1 up and 3 to the right. 1, 2, 3. 1 up and 3 to the right. So then if I join the points on that line, there's my inverse equation. Y equals 1/3 x minus 2/3. Is this inverse function, or this inverse of the function, also a function? Yes, this green line is a function. Okay, the last part. With the graphing calculator, I'm not doing. You can go through and you can learn how to go through the steps. What it will do is if you put an equation in a calculator and then go through this process, it will draw the inverse of that equation. I don't like doing that because you guys need to know the characteristics. When it comes time for a test, if I give you a function without giving you the equation and ask you to do the inverse, and you don't know how because all you ever do is use the calculator, it's not going to help you. So you can go through that part on your own, but I'm not going through it as a class. So there's not a lot of things that I don't show you how to do on a calculator, but this is one of them. So I'm going to give you the questions, and tomorrow we're going to finish the chapter. We're going to do the second inverse lesson tomorrow before we go to Cummings Lake, and then that'll be the work that we'll finish up. We probably will finish the assignment, the lesson tomorrow, and I'll probably start the new chapter on Monday. So the questions.